Let's look at a few more problems. Okay, d3y by dx cube plus d2y by dx square minus dy by dx minus y is equal to cos 2x. Now in d notation it can be written as d cube plus d square minus d minus 1 y is equal to cos 2x. Aux equation would look like m cube plus m square minus m minus 1 equal to 0. Let's factorize this. We get m square m plus 1 and minus 1 times m plus 1 equal to 0. And this would be m square minus 1 m plus 1, and if we take m square minus 1 equal to 0, we get m plus 1, or let's do it like this itself, m plus 1 times m minus 1 times m plus 1 equal to 0. So which means we have repeated roots. So m will be minus 1 minus 1 1. So therefore our complementary function would be c1 plus c2x e to the power of minus 1x plus c3ex. Okay, let's look at particular integral. This would be 1 by d cube plus d square plus minus d minus 1 cos 2x. Okay, this can be written as 1 by d cube, let's write it as d times d square plus d square minus d minus 1 cos 2x. Now here what we can do is this d square can be replaced with minus m square, remember? So let's do that. D times minus, this is m, so minus 2 square plus minus 2 square minus d minus 1 cos 2x. Okay, 1 by minus 4d minus 4 minus d minus 1 cos 2x. This becomes minus 5d minus 5 cos 2x. 1 by, we can take out minus 5 out, so we are left with minus 5 d plus 1 cos 2x. Now this d plus 1 is tricky because we want it in d square plus a square format, sorry, d square minus a square format. Now we can't again do this. We need to convert this into some form where we can work on it. So let's do one thing, minus 5 times d plus 1, let's multiply it with d minus 1. Okay, so numerator also d minus 1 cos 2x. So the denominator will become d minus 1 by minus 5 d square minus 1, and we know d square again can be substituted by minus 5 times minus 2 square, that is minus 4 minus 1 cos 2x. Now this would be equal to d minus 1 by minus 5 times minus 5, that is 25, and cos 2x. Now let's distribute this d minus 1 or cos 2x to d minus 1. So we get 1 by 25 d cos 2x minus 1 by 25 cos 2x. Now this is d is nothing but dy by dx, right? So when we differentiate cos 2x, we get minus sine 2x times 2 by 25 minus 1 by 25 cos 2x. Now this becomes 1 by 25, we can take it out, minus also we can take it out, so that we are left with 2 sine 2x minus or plus cos 2x. So our final solution is y is equal to c1 e to the power of x. Am I right? C3. Okay, first we have taken the repeated roots. Okay, no problem. So this would be c1 plus c2x e to the power of minus x plus c3 e to the power of x. Am I right? E to the power of x minus 1 by 25 2 sine 2x plus cos 2x. Yes, let's look at another problem, and this will be more of a result kind of thing, so that we can use that knowledge in other problem solving. So 1 by d square plus a square sine a x. Since it is d square, we can't just substitute minus a square, because then minus a square plus a square, it becomes 0. So we can't have 0 in the denominator. So what we'll do is we will convert this into some other form using complex numbers. So d plus ai times d minus ai sine a x. Now here, if you notice, if you multiply this, this is a square minus b square form. So d square minus a square I square. Now because of that I square, it will become d plus a square, which is what we start off with. Okay, now this can be written as 1 by d plus ai, and we take this together. Yes, we take it as 1 by d minus ai sine ax. Okay, or what we'll do is, since we are not very clear about this, we need to convert it into some other form which we are familiar with. So remember, we have the identity e I theta cos sine with an I. So you have two parts to it. One is the complex imaginary part and the real part. And here we have sine ax. So which means it is the imaginary part. So let's focus on the imaginary part. So what does it mean? Here we have I theta. So here theta would be ax. So e to the power of I ax. Only the, remember, imaginary part. Okay. So now this is something we are familiar with. This can be written as 1 by let me write it, IAX times 1 by m plus IA. Yes, I 1 by this is going to be d plus m minus AI. AI is nothing but m, right? So AI part would disappear, right? So d plus m, here m is AI minus AI, so this would disappear, and since nothing is there, let's take it as 1. So this becomes 1 by d plus ai eiax times x to the power of 1 by 1, right? Okay, so 1 by d plus ai eiax times x. Now it is not in the form of e to the power of mx. It was in that form in this case, but now we have it in the form of e to the power of mx times v. Let's take care of this. Now here what happens, we already have x by, we can replace d by m, so that is ia. So ia plus ai becomes 2ai, and eiax is cos ax plus I sin ax. Now let's take I in, so it becomes 2a cos ax by I plus I sin ax by I get cancelled. Now if you want to bring the denominator to numerator, the I, we take it as minus I. Now to verify that, let's rationalize this. We get minus I square by I, and minus I square is 1 by minus 1. Sorry, minus I square is 1 and denominator is I. Yes. So this becomes x by 2ai minus I cos ax cos ax plus sin ax, and now we can 2a sin ax minus I cos ax. We are interested only in the imaginary part. So 1 by d square plus a square sin ax is equal to the imaginary part of the above, okay, which is equal to, remember, imaginary part, so minus x cos ax by 2a. Now if the statement was 1 by d square plus a square cos ax, in that case it would have been the real part of the above, which would be equal to sin ax. So x by 2a times sin ax. You need to remember 1 by d square plus a square sin ax is nothing but x cos ax minus by 2a, and 1 by d square plus a square cos ax is equal to x by 2a sin ax. Okay, I think that's enough for today. Bye for now.